So what are you guys?
We're part of the Smartwood family.
Problem number 3. This is a problem that students sent in. It's very, very nice. It's actually, see if I can do this right. I think you set this to be 2r, and then I think for a radius of r, you put a little circle here, right? Something like that. You know, it's just two-dimensional. We assume uniform density, right, on the surface of this disk, okay, or on the disk. And let's say this right here is solid disk, and this is a hole cut out. So the question for you is, where's the center mass of this guy? Okay. Now, there is a version, of course, of center mass where you can integrate and do things like that. It's totally fine. But this one's really nice because we don't need to do that. There is one property, though. Do you agree that if you have 3 guys, so if you want a video on this, we could talk about it, but it's pretty believable. If you had 3 guys, A, B, and C, like this, okay? And let's say I want to compute the center mass. You can do it. I mean, you can even use a formula to show it. But you can do it in pieces. Like I can compute the center mass of these 2 guys. And let's pretend it's right there, okay? And then I can compute the center mass of these 2 guys and get the final answer. You might be like, that doesn't seem fair, because it's like these guys, you group over here and you group there, and they seem to be equal, right? They're not. Because remember, when you're computing the center mass, the mass matters. So when you collapse these guys, if they all had the same mass, this would be 1, 1, and 1. But when you collapse these, this would be 2, and that would be 1, and this would be worth more. Okay? So it does work out. Okay. Based on that idea, I think we can compute the center mass of this guy very nicely. Okay. By the way, set up the coordinate system any way you want. I'm going to set it up to where literally the vertical and the horizontal, right there at the center of the circle, is going to be 0, 0. Okay? And I want to compute the center mass. So first things first, we didn't talk about it yet, but we did hint at it. You can look at center mass vertically and horizontally. So I think vertically, that's mellow. The top looks just like the bottom, so the center mass is going to be right here. So vertically, it's going to be along this line. So center mass is going to have a y-coordinate of 0. What about horizontally? That's a little bit trickier, because it's not symmetric. Okay? So I kind of feel like since you have all this filled in, and there's a gap there, the center mass is going to lean to the right. But I don't know how far to the right. And you could do it with calculus, but that's a little bit tedious. So why don't we try it this way? The thing about it is that I don't have 2 guys that add up, because I have empty space in this funky shape, right? Like this crescent type shape. But what I think we should do instead, though, is use that to our advantage. Actually create some pieces. So imagine you have the entire disk. And the radius is 2r. Okay? Nice way to think about this. So if you have the entire disk, right? Now we can piece that together, because the center mass of the entire disk, number 1, it's easy. It's perfectly symmetric. It's going to be at 0, 0. Second, how does that relate to this guy? Well, you could take the center mass of this component, assuming it's filled in, okay? And you can add it to the center mass of this component. Ooh, sorry. Assuming that's filled in, and you will get the total center mass. So this guy is what we're going for, right? And what about the yellow guy? Well, the yellow guy is not even there, right? But as the center mass is easy to compute, and we're going to use that to our advantage. Okay? So do you agree that if you take the yellow disk, let's call it yellow, and we add it to the brown disk, or the brown crescent, I'm sorry, like this, right? In terms of center mass. So, sorry, the camera stopped. So, what about this guy? This one's actually pretty nice. I'm going to draw it over here. If you look at our yellow disk and imagine it's filled in, it's perfectly symmetric. So the center mass is going to be right in the center. But since this is a radius of r and this is 0, 0, this guy's coordinate here, right, is just going to be negative r, comma 0. Okay, so this is going to be negative r, comma 0. Okay, so negative r, comma 0, right, worked in with the center mass of this guy, whatever it is, should give us the center mass of the red guy. Okay, but you know how to do that. We'll just go back to our general form. So, and the notation can be kind of funky, but let's do it. So we're going to take the mass of the first guy, let's call it m yellow, times its center mass. Okay, now remember, the thing is I'm getting the coordinates here, but we already know that the vertical component is going to be right at 0, because it's symmetric top and bottom. So really the only thing we care about in terms of center mass is going to be left to right. Okay, so I'm just going to worry about this coordinate and that coordinate. Okay, so this guy's score is going to be negative r. Okay, and we're going to combine that. Remember the general formula is m1 times score 1 plus m2 times score 2 divided by the total mass. Okay, let's do this. The mass of the brown crescent, okay, times its center mass. We don't know that. That's what we're solving for. So I'm going to call this, So I'm going to call this center mass, okay? Divided by what? The total mass. But the total mass is the mass of the red guy. So I'm going to say total mass, right, is equal to, well, it's 0, 0, but we're only worried about the horizontal components, 0. That makes this really nice. So now that we have this equation, what I'm going to do is multiply both sides by m. M times 0 is still 0, right? Now we don't even need the picture anymore, but let me try to clean this up. Okay, so we have negative r times m sub y plus the center mass that we're looking for, whatever this coordinate is, times m sub b for brown, okay? Sorry if that was confusing. I'm going to call this y for yellow and b for brown, okay? And those guys are going to sum to 0, okay? All right, no big deal. Now, how do we get this? So you know what I'm going to do? Let's just solve it. So we have the center mass is going to be, bring this guy over, positive r times m sub y divided by, apparently, m sub b. Okay, no big deal. But the beautiful part is this, since it's uniform density, that means everywhere here, for the same area, you get the same mass. For solving for the masses, all we really have to do is compare the areas. And we don't even need to solve for the area. We can just look at the relative area. We will solve for the total area, but the only thing that matters is how does the area of the y guy compare to the area of the b guy? That's it, okay? And does everybody understand that? Because it's uniform density, meaning for a given area, you get the same amount of mass. 1 square meter gives you a certain amount of mass. 2 square meters gives you double that mass, et cetera, et cetera. If you want the relationship between the masses, right, then all you have to do is look at the relation between the areas. Okay? So let's look at that relationship. So m sub y is this guy, but this guy has a radius of r, so its area is I big R squared, right? All right, what about this one? This one, we can compute this. This is actually not that bad. The total area here, because this guy would have had a radius of 2r, is pi 2r squared, which you know is 4r squared pi. Okay, just multiplying it out. However, that would be the entire guy here. And what we want is we want this guy. All you have to do is subtract this, but we already solved for that. We said the area of this guy is pi r squared. So you subtract pi r squared. Okay, all right, my bad. I don't know why I wrote it that way. Okay. Anyway, 4 pi r squared minus pi r squared is 3 pi r squared. So now when we plug in, we're just going to get 3 pi r squared. This is very nice. It gives us r over 3. So it turns out the center mass of our crescent shape, okay, is going to be r over 3, positive r over 3. So if you go out, this is supposed to be 1r, second r, a third of that, so somewhere right here. Okay, so sorry the picture's a bit off, but if this were the midline, it'd be over here, r over 3. So an interesting way to compute the center of mass. Okay, do one more, and then we'll let this stuff go.